Okay. All right. So I have a couple of kind of refresher review questions. So here we have a diagram of the Hawaiian Islands created by a hotspot in the middle of the Pacific Plate and the Pacific Ocean. So number one, which island is the oldest? So A, B, C, or D, which one is the oldest? And anybody can say the answer or put it up in chat, either way. Which one of those islands, A, B, C, or D, is the oldest?
D.
Anyone?
A.
Not D.
Is it C?
No, not C.
A.
Any other ideas? So the oldest island is A. The oldest island is A. So if you remember, the hotspot pretty much stays in the same place. It doesn't really move that much. But because A is the furthest away from the hotspot, you know that it's the oldest. Anytime, this is kind of a test-taking tip or something, or something to remember. In something like this, you have A, B, C, D. If the question is asking for the oldest or the youngest or the newest or any sort of extreme, like if it's either the greatest or the least or anything like that, it's almost always going to be one of the ends. It's going to be one of the outside options if they're in order. So here we have A, B, C, D, it's in order. So if I'm asking what's the oldest, it's probably going to be either A or D, because B and C, they're in the middle. So they aren't the youngest, they aren't the oldest, they aren't the closest, they aren't the furthest. So it's just something to kind of remember. Now, if they were mixed up, then that's different. Now, which direction is the plate moving? So remember, the hotspot pretty much stays in one place, and then the plate moves above it. So which direction is the plate moving? And you can use the compass rose here to help. So is it moving north, south, east, west, northeast, northwest, southeast, southwest? One good way to figure this out is because we know that A is the oldest. And in the past, A was right down here over the hotspot. So if, where is this? So if A was down here, but then has since moved up to there, what direction is that if we're using that?
North.
Yeah, it's pretty like north, northwest. You know, I mean, it's kind of, you know, in there. So that's kind of a good way to figure that out. Like I said, you know, because we know that A was down here, but it's up here now, so it has to move, you know, in what direction. Good. All right. All right, so moving on. All right, this first vocabulary word is viscosity. And viscosity it's a fluid's resistance to flow. So viscosity measures how much a liquid does not want to flow. So I have a little animation here, this kind of this white silver liquid and then this purple liquid. So these are both fluids. Now, if a fluid has a low viscosity, that means there's not a lot of resistance to flowing, so it flows really well. It's a lot like water. Water flows really well. I mean, it, sloshes around in cups, it'll splash out, it'll spill, it'll, flow all over the place. So water has a low viscosity. Now the purple one down here, this would be an example of a fluid that has a high viscosity. It does not want to flow very much. It's very thick. Can anybody think of some sort of a fluid, some sort of a liquid that would have a very high viscosity, that would be very thick, that would not want to flow very much?
Glue.
What was it?
Glue.
I still couldn't hear you. I'm sorry.
Glue.
Glue. That's a great example. So just like the white school glue is a really good example. Anybody else have one? Something that's used as an example a lot is honey, because it's very thick. Syrup, like pancake syrup or something, is very thick. Temperature is also something that can affect viscosity and can change viscosity too. The warmer a fluid is, the lower the viscosity. So if you've ever had honey or syrup or something and you've heated it up, you know that it flows a lot faster. It flows a lot more easily. Or if you've had honey or syrup and you put it in the refrigerator and cooled it down, then it's really thick and it has a very high viscosity. It does not want to flow. So that also happens with lava. So here we have a couple of examples of lava from Hawaii. So this top one, this very rough, very sharp, jagged, that's called a'a lava. And then this bottom kind that flows very easily, it's much smoother, that's called pahoehoe lava. So the a'a lava does not flow very well. It has a very high viscosity, but the pahoehoe has a low viscosity and flows very well. So here we have a couple more examples of that. So here's the a'a lava on top and the pahoehoe lava down below. So very high viscosity, very low viscosity. All right, so here we have a picture of a volcano and a crater, which is at the very top. And I just wanted to remind everybody, I know there are a lot of words that have more than one definition and, some specific definitions. Just remember that when that happens, when you come across a word like that, make sure you're using the definition that applies to what we're doing in class. So right now we're talking about volcanoes. So for example, the crater, which can be caused by volcanoes or by meteorites or something like that. Let's just talk about the volcanoes since we're not talking about space or anything like that right now. Something else that's similar to a crater, but different, is something called a caldera. A caldera, like I said, similar to a crater. So in this diagram, we have the crater up here at the top of the volcano. The way a caldera forms, and this doesn't happen with all volcanoes, it just happens with some. Below the volcano, you have this magma chamber that's full of magma, and that magma feeds that volcano, feeds the magma to that volcano so it can erupt. Sometimes, after the volcano erupts, that magma chamber doesn't fill back up with magma. It's just open. And what can happen is the whole volcano cone can collapse into that empty magma chamber and form a caldera. So like I said, this doesn't happen with all volcanoes, but it can happen. So, they're a lot bigger than just a crater. But it's all because this magma chamber that was full of magma is empty. And so all the weight of the volcano and everything, it just collapses. It can form a lake. So here's an example of a caldera. And this one even has another little volcano in it. Here's another example. And this is actually a lake that's called Crater Lake. And it's out in Oregon on the Pacific Northwest. And then this last picture, this is just a computer generated image of the magma chamber that's below Yellowstone National Park, and the caldera that is Yellowstone National Park pretty much. I think that's about it.